a variable. So in this example, we are trying to create a class called set, okay? And we have decided to use dynamic arrays to store the tags. So this means tag array is an array of tags, and it's a dynamic array. And the constructor for set is this new function. In this case, we really don't do much. We just create a zero length dynamic array and assign it to tag array. So we have created an empty set. The display function is straightforward. We print flower bracket and print all the elements of the tag array and print the closing flower bracket. That's all. If you want to print, let us say we want to have maximum of 6 or rather 8 elements in the set. Okay. So maybe that can be given as an input. We can say um, int max. In that case, we could have created once and for all max elements or something like that. Or we could store it here. So here we can say this dot max equals max. So the value that the user is providing will be returned into this max. So we know that this set can have at most these many elements. So add, see if we have decided to have maximum of 8 elements or whatever, then first before adding we should check. Okay. So if tag array dot size is already 8, then we should simply give an error and come back. Set is already full. Otherwise, we go through each element, and if it's already there, we ignore it. We don't add it. So here we can say dollar display. Tag is already in the set. And we can display that. So if it doesn't break out of the loop, that means this element was not there. Okay. So we can check if the element exists, which we have said here. Then we don't do anything. But if the element doesn't exist, then we make room for one more element and add the element at the very end. Remove will temporarily create a new set called temp, and it will go through the entire array and copy those elements which are not equal to t into that array, into that set. Then we delete the existing element tag array, and then we know how many elements are there in the stem, and we recreate tag array with that many elements, and then copy everything. So if you add 6 twice, we should somewhere check that it is, if the user is asking us to check something that is not in, remove something that is not in the array, it's a little bit waste. Right? Yeah, not very efficient if somebody asks us to remove something that is not in the. So we can try s dot remove 11. 11 is not in the set. So we should not do anything, but it's a wasted computation. This time we have to say 8, and here also. Fact 6 is already there, and we are trying to add. Let us also see whether we can add s1 dot add 11, s1 dot add 10, s1 dot add 5, 5 is already there, 15, s1 dot add 23, s1 dot add. So we may be adding more than 8 elements, so it should give me an error. We have to add one. But here it adds. The saying set add is slow. Should does it allow return? Yeah. So you should return. You should not continue. Okay. Any doubts? See, we could have done the same thing by using something like this. For I equal to 0, We could create a tag elements. It's, so let us create tag elements dollar. Okay, that means elements is a queue of tags, and that can be initialized to 11, 10, 15, 23, 44, 40. So instead of adding them one by one, you could create int I. You can say for I equals 0, I less than elements dot size, I plus plus, S1 dot add elements. So these are how you can use the existing data structures. It behaves exactly the same way. Is that clear? So I let you write the other ones like difference. Okay, it is just a little bit of coding. Okay, you can do it. Any questions? So let me say send this to Professor Vinay Sahula. So exercise for you is complete the exercise by allowing set difference, set intersection, set union. You can also have a set size. You can allow a size which tells you how many elements are in the set. Okay, so please do that exercise. And if you want, you can also do the same thing in using Q. Try the same exercise using Q. Okay. So everybody got a feel for classes. What about the others? Anything that you didn't understand? Okay, looks like people have not quite understood. Huh? I get the feeling. So nobody is saying anything. So let us create another class. Okay. Suppose you want to create a class called ALE. What does the ALU do? It can perform several operations. It can add the numbers, subtract, logical and, logical or, etc. etc. So how to initialize an ALU? What is the new function? Function new. What do you think this should be? What do you think you should provide? Maybe the size or something like that. So if the user provides a size, you can store it as an integer inside the. So it copies, this size into this size. So that could be a simple, initialization of it. What about the ALU? What are the functions it supports? So let us try using the enumerated data type. So enumerated data type, add, subtract, multiply, and or XOR.
Shift also.
Shift, left shift, arithmetic shift right, logical shift right, left, logical shift left. Either you can define this as a type. So in this case, op type becomes an enumerated data type. We could also have two input registers and one output register. So we could say input registers are, let us say, A and B. So bit A register and bit B register. And if the size is given, we can possibly initialize, right? A equal to new of size and B equal to new of size. You agree with me? So once the sizes are provided to me, then maybe I also will need a uh, bit result. And maybe there are some flags like overflow, carry, sign, okay, to tell us whether the sign of the result is negative or positive or whatever. So when we initialize the ALU, we make the size equal to whatever is the size provided. We create these two registers or these three registers, and maybe we can initialize overflow to 0, carry to 0, sign to 0. So that will initialize the ALU. Now we have to define, a task or something like that, which will do execute. And maybe we can send the op type, right, as an input. So we are telling the ALU to execute this operation. So here maybe we have to use the case statement. So if it's an add operation, we add A and B and put the result in result equals A plus B. I think carry is also needed. So out carry and result together gives A plus B plus in carry. Similarly, subtract out carry result is A minus B minus A. Mul the multiplication really cannot be done with the number of bits, but we'll sort of assume that result becomes equal to A times B. You need twice the number of bits in the result. So this will only work for very small numbers. Then and result equals A and B, or is result equals A or B. XOR is result equals A XOR B. Arithmetic shift right. The result equals um, the arithmetic shift right. Which one should we shift? A or something? We'll assume that A will be shifted. So this 3 means it's arithmetic shift. When we three of them, it's arithmetic shift. If it is 2, it is logical shift. And LSL is A less than. So we are assuming that A will be shifted. And at the end, we have to check if there is any overflow or carry or something like that. Maybe initially we can set out carry to 0. And whatever carry results from add or subtract, let us say we assign that to carry flag. So there is a carry flag. So we can use that. So in the case of add, the overflow flag, carry flag is same as out carry. Sign flag is result of wait, wait. I have used this like hey, this may not work. Huh? A plus B will not because this is a dynamic array. You can't add like that. If it is a simple, you know, I can't add this like this. So this idea is not very good. So if you want a programmable ALU, any number of bits, you can't do it this way. So we'll have to again copy. Okay. We have to copy the value from. So it's a little clumsy. This is not good. See, we'll pretend that they're all, let us not make this programmable thing. See, let us just keep it simple and make it ALU of 4 or 8 bits. Okay, it's going to get really complicated. We'll assume that it's always 8 bits.
So can we use parameter?
Even that will indicate stuff. So we'll keep this 8 or something like that. A and B are both simple resistors. And result also. So this is not required. So for add, we perform the addition by A plus B plus in carry. Carry flag is set. Sign flag is equals result of ALU size minus 1. The most significant bit will represent the sign, right? What about overflow? See, we are trying to add two positive numbers and the result became negative. There is something wrong. So we could try that if A is the A of value size equals 0, yeah, I think there was a question about commercial simulators. You cannot run the commercial simulators as students. Okay, you will have to your college may have a Cadence Xcelium or something. Okay, so IKS cannot handle a few of the things. Okay, very few constructs are not handled by IKS very well. For that, you have to see if your college has a license. If both the inputs are positive, and should be and result of ALU size minus 1 equals 1. That means it is negative. This is one condition. Or the other way around. A of ALU size minus 1 equals 1. That's it's a negative number. and b of ALU size minus 1 equals 1. That means it is also negative. And result of ALU size minus 1 equals 0. In either of these cases, we should have, so we can simply set this to overflow. So this will become 1 if any one of these is true. If neither of them is true, it will ignore. Then we have to have an end. So initially, maybe we can also set overflow carry flag equal to 0 and sign flag equal to. We will initialize everything to 0. In subtract, it will be somewhat similar. I suppose all of these is still the same. No, overflow and subtract may not be the same, right? Sign is okay. I don't know when we say that overflow is happening in negative. I don't think this is entirely correct because in when you subtract, of course, it can happen. When you have a positive number and subtract a larger positive number, the result will be negative. So that is not, so we have to think of a better. Right now, let us not spend too much time on trying to understand the carry and all of this. Okay, we'll do a few. After all, our intention is not to, really implement an ALU. We may have to have an operation called load, which loads the registers. So maybe we'll have a, and it will give me the bit ALU size minus 1 to 0. This is the, so we can write A equals operand. So we can have a load B, which is very similar. We can have a display, which will display A equals B equals carry n equals carry in also has to be loaded. Task load carry in. correct? So here we have to say in tally, then result equal to out carry equals overflow equals sign equals and display all of them. A is in tally result out carry and overflow flag sign flag then carry flag. Now these are the things we are displaying. We have a display, we have loaded, we have executed. Now we'll try to create a test case. Let us make sure that there are no errors at this stage. Carry flag. So testing can be done by instantiating one copy of the ALU. I think we just call it ALU. And let us call that as my ALU. And I don't think new takes any arguments, right? It's just new. Initially, we thought of giving the size of the ALU, etc. But see, it becomes very complicated because then the dynamic array. See, we can't simply do additions of dynamic array. We'll have to think of so many. It's not impossible, but it's too painful. All right, initial ALU dot load A. We load A, load B, etc. Let us say we load the value 45. ALU dot load carry. We will say it is load 1. Okay, so we load all these guys. Then we perform the ALU operation. We can do display first. And ALU dot It's called off, I think. You execute. Here you execute. Right. Then you don't display. It's not ALU, sorry, my mistake. It's my ALU. My ALU. Correct? Yeah, it will be correct. This is, I think this is 45. This is 70, 55. 45 plus 55 is 100. 100 plus 1 is 101. So this is 101. So addition is happening. There is no carry. So let us increase the number. So this time we may find that there is an overflow because the number is too big to be represented. The overflow has come. Okay. And also it has become a negative number. So see 45 plus 75. See in the 8-bit register, we can go from minus 127, I'm sorry, minus 128 to plus 127. So anything outside that range, it will say overflow. Right? We can also try my ALU dot logical shift left. And then so that should shift A. So you can see A has been logically shifted. So after that, we can try arithmetic shift right. Okay. So this time it will give 1 1. Okay. Arithmetic shift right didn't work. Huh? Hmm. That's why I didn't. Anybody knows why arithmetic shift right didn't work? Because we had a negative number, right? When we added, suppose I display here, then before arithmetic shift right, it has become a negative number. So when I do an arithmetic shift right, ideally I should have got a 1. Hmm. What is the reason? Let's make sure that we understand this. We forgot to put it down. What is the way to shift right? Arithmetic shift right. Anybody knows?
It's 3 greater than symbol only.
Yeah, that's what I thought. It could be. I think I know what would be wrong. See, it may expect me to say sign here. It may expect me to say signed bit sign. Yeah, now it's okay. See, you have to say bit signed, otherwise it assumes that it is an unsigned. So here we had a negative number. So when you write shift, you get this one. Okay. So we have to declare them as, but now our carry overflow got. I want you to work through this overflow carefully. Okay. So right now we are not doing a good job of this overflow. Even this carry didn't seem to work correctly. So here it is taking, what is this number? 75 I gave, no? 75 plus 65. See, that is an overflow because the result of that addition has become negative. See,
So for
let
this,
me
we have to
display
compare
after
the
everything.
carry of the last MSB and
Huh?
the previous MSB position.
Maybe display is wrong. Huh? Maybe I should do display everywhere. So display after loading, display after adding, display. That will work. Now it's okay. So there was an overflow because when we added two positive numbers, we got a negative number. Okay, so that is an overflow. Similarly, you can try subtract. Sign is negative, and it is claiming that there is no overflow. So we have to check that. Okay, we have to check that. So did this give some useful insights? Did you understand something more about classes? So you understood about enumerated data types, right? So this is a very useful thing. If we did not have enumerated data types, this program would have been so much more complicated, and debugging it would have been so much more difficult. Right? So it helps a lot. We could also have a zero flag that I forgot. Zero flag is when all the inputs become zero. If the result becomes zero, it becomes that I will let you handle. So at the end, we can check whether zero flag equals result equal to something. We have to display it somewhere. So here, none of them had zero answer, so it may not give any problem. What do you think this will do? See, what it did was I just copied B into A by saying load A with the B value. So I just loaded A with the same value as B, and I performed the XOR operator. What happens when you perform XOR of A and B? A and B are identical. So what happens to the XOR? It will become zero, right? So that is what has happened. Okay. If you have two identical values and you XOR them, they will be zero. That is why the zero flag became. So only I think overflow flag has to be slightly checked, and there may be other operators that we may not be handling. So what is the advantage of doing something like this? See, it's much easier to check this model than the hardware model. See, the hardware designer is actually designing the hardware, and his attention span or other attention may be deviated because of all the details that are there in the hardware. Right? On the other hand, when we do this, it's relatively easy, isn't it? It's no big deal. We are treating it as a simple model, and we are, making these changes. So testing or verification becomes easy when we build a model like this. Is it clear to everybody? No, this is not synthesized. Classes, etc. items. Why are you saying that we could have used 000, etc.? See, that is what we don't want, right? We want slightly enumerated data type avoids all that. Okay, so we should use whatever is available. Okay, okay, let me give this to you guys. Any questions? I feel except two people, nobody is asking any questions. So my worry is people are not understanding or something like that. Any questions? You can read, no? Why are you asking me this? See, these kind of questions you should not ask. How is two left different? Those things you can read. Hmm. But I want others to ask questions. Anything that you guys want to know. I'm worried that I have lost you guys. Hello? Let me open up the people's tab. Any questions? Akhilesh, Kumar, Roy? Any questions? Ashwini? Athar? Oh, it's just attendance for the sake of attendance. Huh? Log in and go away. Debashish Acharya? No questions. Okay. All right. Well, so Radha, you got the idea. Okay, very good. Now, can I expect that you will be able to similarly model a cache controller? Is that a fair assumption? Can you build a class for the cache controller? System Verilog is new to me. Just trying to observe and understand. Okay. So, what has been interesting in this so far and what has not been very interesting? Let me put it that way. What have you found interesting in System Verilog? Anything? Some things are same as Java. It's okay. So that way, mm, mm, it is supposed to have been inspired by C++. Okay, not, I don't know that Java is, okay. All right, let's move on to interface. Okay. So we have understood the class construct. Let us move on to maybe interconnects, interface. So this is in page 186. We, when we have already defined interfaces, right? When we define a module, we specify which are inputs, which are outputs, and all that. So you can separately build, okay, which one you can't test rather? Only one or two examples you will not work. Others will work. Which one you are saying cannot be done? Why? It works in Icarus, no? Doesn't it work in Icarus? Let me see. Works, no? It works in Icarus. Why did you fail that it doesn't work? A few things are not implemented. See, I think associative arrays are not implemented. Maybe a few things like that. Okay, but Icarus Varila will, happily do most of this stuff. So we have no, we shouldn't complain. Okay, today you're all very lucky because these are all freely available. Okay. So you cannot, there is no excuse for not doing. So Radha, is it clear? It works here. I can do the same exercise in iCare as well. First time I have been using this tool, learned it. Okay, that's okay. But what I'm trying to say is, see, we sometimes start thinking that, we don't have this, we don't have that, our institute doesn't have
వాళ్ళకి
this. Frankly,
ఫ్యాకల్టీస్ ఏంటంటే
today there is
కానీ
not,
లేదా వాళ్ళకి తెలుసుకుంటా ఉంటాం స్టూడెంట్ పాయింట్ ఆఫ్ వ్యూ లేదు. బీటెక్ వాళ్ళు ఉన్నాయి బాగా చెప్తారా? బీటెక్ వాళ్ళు ఆబ్వియస్ వెళ్ళిపోతారు. బీటెక్ వాళ్ళే కదా వాళ్ళకి ర్యాంకింగ్ పెరిగేది. ర్యాంకింగ్ బీటెక్ వాళ్ళకి ఓకే ఉంటారు. ఎంటెక్ వాళ్ళని పట్టించుకోరంట. నాకు చెప్తారు జనాలు చాలా మంది. వాల్యూ సర్టిఫికేట్ ఎన్ఐటీస్ ఐఐటీస్ లో ఎంటెక్ వాళ్ళని పట్టించుకోరంట. అదే పిహెచ్డి వాళ్ళని బీటెక్ పట్టించుకుంటారు. పిహెచ్డి అంటే వాళ్ళకి రీసెర్చ్ పేపర్స్ వస్తాయి కదా, స్కోరింగ్ ఉండేది. బీటెక్ అంటే అది ప్రెస్టేజ్ కాబట్టి ఎంటెక్ పట్టించుకోరంట. ఇంకా మంది చదువుకోవడం మనకి ఇంకా సెల్ఫ్ స్టడీ అక్కడైనా కానీ కంపెనీస్ వస్తున్నాయి. కంపెనీస్ పర్లేదు, మంచి కంపెనీస్ వస్తాయి. మంచి కంపెనీస్ వస్తున్నాయి కానీ ఈసారి క్యాంపస్ వరంగల్ కి ప్లేస్మెంట్స్ బాగా డౌన్ అయిపోయినాయి. ప్లేస్మెంట్స్ కూడా వేరే చోట పర్లేదు. ఇప్పుడు సూరత్ చాలా వేసింది. ఊరికెలా ఓకే, ఊరికెలా మా ఫ్రెండ్ ఇటువంటి నాతో పాటే ప్యారల్ ఇప్పుడు వాడికి ఎంటెక్ సెకండ్ ఇయర్ అయిపోయింది. 15 LPA వచ్చింది. మా తమ్ముడు కూడా ఎంటెక్ ఏమో సిల్చర్ ఎన్ఐటీలో చేశాడు. సూరత్ కల్లో పిహెచ్డి చేశాడు. తన ఎలక్ట్రికల్ డిపార్ట్మెంట్ మీదే జాబ్ వచ్చింది. 1 lakh per month.
is it possible for you to turn off your
ఏదో ఒకటి వచ్చింది కానీ చివరికి అయితే ఫైనల్ ఇయర్ వచ్చింది. ఏదో గ్రేడ్స్ అనేది కొంచెం మేనేజ్ చేసుకోవచ్చు. ప్రెసెంట్ అయితే నాకు 8.07 అది అది అలాగే కంటిన్యూ తగ్గకుండా చూసుకోవాలి. అవునవును, ప్రాజెక్టేగా ఇప్పుడు ప్రాజెక్ట్. అదే గైడ్ తో కొంచెం ఫ్రీగా ఉండాలి. అదే సార్, గైడ్ తో నేను ఫ్రీగా ఉండాలి. ఆయన వెళ్ళారు సమ్మర్ ఇంటర్న్షిప్. గైడ్ సాయి ప్రకాష్ సార్ అని. సాయి ప్రకాష్ ఆంధ్ర ఆయన వైజాగ్. అయిపోయింది. ఎలా ఉంటాడు? చాలా స్ట్రిక్ట్, మంచి అంటే పాయింట్ ఆఫ్ వ్యూ పంచువాలిటీ అండ్ బయటకు వస్తే ఫ్రెండ్లీ ఉంటారు కానీ పంచువాలిటీ వర్క్ చేయాలి. సిన్సియారిటీ వర్క్ అండ్ టైమింగ్స్ కానీ ఇప్పుడు లైక్ ఎలా ఉంటుందంటే ఎలా అయినా కానీ ఒక పర్సన్ గైడ్ లైన్స్ కింద ఎలా వర్క్ చేస్తారు అలా ఉంటారు. గైడ్ లైన్స్ ఫాలోస్ అంతే, అలానే ఉంటుంది. అదే మంచిది అలవాటు మనకి పడింది. అదే సార్, ఇక్కడ మనకి ఇన్షియేట్ చేసి ఇక్కడ యాక్చువల్లీ ఇప్పుడు ప్లస్ ఏంటంటే సార్, మనం ఇన్షియేట్ ఇక్కడ నేను ఇక్కడ వరకు వచ్చినాక ఇన్షియేట్ ఇక్కడే నేర్చుకున్నాను. బెస్ట్ థింగ్ ఏంటంటే ఇక్కడ ఇన్షియేట్ చేసి తర్వాత అది ఎంత అలవాటు ఏంటంటే లైక్ అఫీషియల్ గా ఇన్షియేట్ చేసుకుంటే ఎంత బాగుంటుంది. రూల్స్ అండ్ మనకి నేర్పిస్తారు కదా, అలానే గైడ్ లైన్స్ వల్ల కూడా అంతే. కరెక్ట్, దానివల్ల యూజే కానీ లాస్ ఉండదు. సరే మరి బెస్ట్.
right? All right. So just be aware that these are all good tools. They are available fairly, easily, right? So make use of these tools. Okay. In fact, you should use them in your teaching. Okay. There is no need to complain that cadence tools are not there and synopsis tools are not there, etc. Right? We did not have even these many tools when we were teaching VLSI many years ago. Right? We used to have only simple tools like Magic and IRSIM, etc. Right? So with that itself, we used to be able to teach. So don't complain. All right. So let me give this to you. I think I have already come. So I was asking you about that, the cache controller. Is that something that you can try on your own? Can you build a model for a cache controller using very good? So they feels that he can do it. What else? Who else? See, that is how, that is the kind of expectations we have from you. Okay? Is the cache control not clear? And these are also well documented. So cache control is not a new module. You will find plenty of documentation about cache controller. So if you try, you will be able to, create, and that will be a learning experience. The learning happens when you do things. Okay. Is that clear, Radha? What do you think? So Radha, please try. Okay. You will be happily able to do this in system Verilog using Icarus Verilog, right? It is a very widely used tool. Okay, Icarus Verilog is a very widely used tool. Earlier, it only supported Verilog. Now it supports system Verilog also in the past 2 years. When I taught this class many years ago, there was no system Verilog support. We struggled. So we're talking about interfaces. Okay. So an interface sort of tells us what are the inputs and outputs. Okay. And you don't need to. Let me try and give you an example. So let us take the full adder. Normally, I will say input A, B, etc. Right? So instead, let us try an interface. Okay, we can call it full adder interface. And let us assume that okay, Ashwini Kumar Mishra. Sir, I have no knowledge in Verilog. That's why I'm having some problem. Understand? Okay. Where are you having problems? Maybe others are like you too, and they are not openly saying. So you are at least you had the courage to say that I am having difficulty. Okay, it's okay. So tell me, where are you finding it difficult? Syntax. Okay. The syntax you will pick up whenever you learn a new language like C or C++ or something like that. The syntax shouldn't worry you so much. It's the concept that should be clear. Because syntax, it will come with practice. And nowadays, these tools are so nice. See, they are coloring. We should appreciate these things. See, if I make a mistake, the coloring is telling me that I have made a mistake. We grew up without all these things. Okay, the kind of editors that we are used to, that did not have any of these things. It automatically indents, right? So learning the syntax, if you do a few exercises, you will start getting comfortable, right? So the best way of taking advantage from a course like this is, try to practice. Try to take some of these examples and try to do it yourself. That is when you will get the best value. Otherwise, after some time, you'll forget everything that was told. Right? So when you learn by doing, you will not forget. Is that okay, Ashwini? So here we can say FA interface, let us say FA bus or something. So what does it mean? I created an abstract thing called a FA interface, which has these 3 inputs and 3 outputs. And I named it here. This is an instance. FA bus is an instance of this. Just like we created instances of classes or any other data types, modules, we can also, in the same way, create an instance of an interface. Then I can say FA bus dot somehow is a XOR of A in, B in, and C in. So I can say A in XORed with B in, XORed with C in. But this time I'll have to say FA bus. FA bus dot means, see, instead of sending individual bits, I have sent a very abstract thing called as FA bus. See, when I interface my computer to the memory, or let us say, some other IO device or something like that, there is an interface, isn't it? The interface may have a clock, it may have a reset, it may have some data in, data out, right? It's better to bunch them all together in one thing called as a bus. In this example, it's very trivial, so it may not really bring out.
Sir,
Yeah.
how do we distinguish here which is input, which is output in the interface?
We can say input logic. Okay, so that's what. FA, now we have to draw the OR of all these things, right? FA bus dot A in, and it with FA bus dot B in. Then FA bus dot A in, FA bus dot C in, FA bus dot B in. Okay. So this it will understand. I hope interfaces are interface may not be supported. Huh? I'm not sure. So you realize that even I'm struggling with syntax now. I keep making syntax mistakes and correcting them. Okay? So don't worry if you don't know the syntax. So it is pointing out Errors in port declaration. It's what is the name of the book's meaning? Okay. You can see an Indian book that is available is the I think there is an Indian book on system Verilog. Let me show it to you in Amazon. I can show it to you in Amazon. I'll send the details to you. That is affordable. You can buy it. There is a more expensive book on system Verilog, which is I think somewhat it may be a few thousand rupees, whereas this one is a few hundred rupees. I'll give you the references of both of them. Hmm.
Sir, inside this bracket, do we need to list the ports?
No, 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 no. See, here's an example. See, interface simple bus. That's all. And later I can say simple bus. Why it's not there? Do you see any syntax thing here? Interface, end interface, simple bus. I don't think that end and all really matters. Hmm. Assignment. It's not an assignment. Wait. This is assign. You're right. This is assign. That's right. But this problem will still remain. So those other problems will go away. So, mm, what could be the reason then? Interface, simple bus. Think that is the reason. Sorry, I don't understand why it is. I can't think of any reason why it should fail because, as you can see, let us see if that this guy compiles. Okay. That is amazing. This works. So what am I doing differently? Hmm, I don't understand. Hmm. No, that's not it. No idea what is the difference between this and this. I have no idea. This is new. So I don't know quite really. All right. So that is the interface. Okay, we can define the sort of a bus kind of a thing, and define all the wires that are part of the bus, and then use it like this. And in the test bench, so this is actually the design. So we should put that here. And the test bench, you can define a bus called FA interface bus. Let us say main bus, an initial. So here we can go from I equal to 0, I less than 8, I plus plus, right? I can assign main bus dot A in, main bus dot B in, main bus dot C in. I'll assign it to I. So Radha, do you remember what this is? Flower bracket syntax. What happens when I put some things in flower brackets? Suppose I say within flower bracket A comma B, what does it do? It sort of concatenates these and creates one unit. So when I assign it to I, the last 3 bits of I will be assigned to. So I'm going from 0 to 7. So these will get all the last 3 bits. And then I can wait for a unit of time and then say input is I. Excuse me. Output is something like this. And we need to create one copy of full adder.
Sir, this interface is a part of design or test bench?
This is the test bench. The interface bus is here. I'm assuming that it'll take both. I mean, it will be we have to include it both in. If we are compiling separately, it should be there in both. But we are doing it in one go, so it should be there in bus.
Ya malbul saya orang.
Really? It's not strange. No? I mean, I understand. Or maybe that parenthesis is a colon. Let's carry output down. So it's carry out only, no? A little weird, no? And something is wrong in their implementation. See, main bus dot ain, etc. It's understanding. If sum out and carry out, it is not understanding. Oh, it's main bus. Oh, so. My mistake. Okay, my apologies. I still don't understand everything. This parenthesis seems to be required. Okay. The other one, I have no idea why it was not working earlier. Okay. And then this was a very silly error. I myself, instead of main bus, I was giving main bus. Okay. So there is no need to, separately give like this. So is the concept of interface clear to everybody? What is the advantage of interface?
So any
What
of
do you
the
think is
signal in the
advantage? Huh?
any of the signal in this interface will it be treated as bidirectional or something?
What is the question?
The signals in the
Yeah.
interface, like A and
Yes.
B, we are not saying
Right.
it is input or output. So is it in general treated as bidirectional?
You can do that. You can think of it like that. Because it
Okay.
knows, no, the direction it knows. Because here you are, by context it will know.
Okay.
But what is the advantage? Why did we define the interface?
The design become more concise this year.
See, this is a very simple example. As a matter of fact, if you put an interface here, it's an overkill. It's possibly best to leave it as individual bits. But imagine the industry standard buses. Right? They are going to be fairly complex. They have a lot of different signals coming in and going out. So, and during development, people tend to modify things. Right? Initially, whatever they thought, right? During the course of the project, they may make some changes. So imagine that did not have this interface concept. Then everybody will have to design with all these input, output. Then if some change occurs in the IO interface, then everybody has to go and make those changes. You understand, no? Whereas here, only one place we have to change. Suppose I decide to add another logic, let us say enable or something like that. Only if enable is true, we compute something like that. Okay. See, nothing will change. Okay, I'm not using it, that's all. Whereas if I did not do it this way, these guys will give a lot of errors. Okay. So once you define the interface, you can make changes. You can change the size. So you may want to change the size of enable to maybe 3 bits. Okay. No problem. Okay. It will not complain. So it keeps the development a little bit simpler. Okay. That is the advantage of interfaces. Everybody understood?
So this is available in Verilog also.
No, it is not available.
Okay.
So try another example of creating an interface for BCD, the BCD adder. Okay. So I want to see how well you are doing it. Okay. Interface, BCD adder interface. So the BCD adder to take this BCD adder interface. What all will you include? So maybe input is a BCD in. There are two of them. There are two input now. There are two numbers A and B. Both of them are 4-bit. Okay. As a matter of fact, you can call it BCD and declare type def logic 3:0 to BCD. And we give a BCD number. And we have a carry. Now the BCD adder receives a bus called BCD bus. Let us declare BCD A and B. And BCD A equals BCD bus dot BCD in A. B is BCD bus dot BCD in B. So I just copied the A and B. Then we'll make a 4-bit, 5-bit number. I will do it like this. And if carry sum is greater than 9, we add 6. Finally, BCD bus dot sum out must be sum. BCD bus dot carry out. Is that okay? I think always. Hey, did I give you that or not? I think I forgot to end put that in. Hmm. That FA bus, I think I have missed out. Yes, so you can see it works. I don't know what initially we struggled a little bit. Okay. So now you can go ahead and define the top level test module, generate random numbers, and try to add BCD numbers, etc. That I will leave it to you. So that is an exercise for you. Is it okay? It's fairly easy once you get a hang of it. So the test part is not given, right? Test bench yourself. Is that clear? Anybody wants to try writing the test bench? What should I type? You tell me, I'll type. How do I create a test bench for BCD ad? I'll move the design here. So here is where I have to write the test bench. Excuse me. You have to give it a try. Okay, without trying, it will not come. What should I type?
U random.
Huh?
You can use U random to generate for the
Yeah, yeah. No,
numbers.
let me ask somebody, right? Anybody else who wants to volunteer? I want a volunteer to come and help me write the test bench. We'll give 5 marks extra. Anybody wants to volunteer? is you can create a module called test bench, correct, right? Let me pick somebody. Likita, you want to volunteer? Subodh Kumar Panda. Dr. Subodh Kumar Panda, tell me. You seem to be interested. So what should I write here? Yeah, you
So
see instantiation will come. You are right. So to create a test bench, you have to define the module called test bench. Let us say BCD test. Okay. Next, you have to instantiate. You are absolutely right. So what should I write to instantiate? Let me ask Hemant Jain. How do I instantiate?
so design name
Then
and a copy.
design name is what in this example? Where is the design name?
After the module name.
Hmm, okay. Is it this?
No, that
Where is
is
the
test
design name?
bench.
Where is the design name?
In design.sp after module that name.
Okay. Correct. All right. Then what should I do?
We need to map the input output.
We also need to instantiate,
Copy
no?
name.
I mean, the
Copy
name
name.
of the instance you have to give. Okay.
Yes.
My BCD or something like that. You have to. So what are the inputs and outputs? What? How will I create an input output now?
You can give any name with
No,
respect
wait. In
to
this case, I had to use the interface. No,
yes.
I don't want to
So,
use the. What
so I
should
have
I
to
say?
use the dot operator.
Dot
So
operator. Okay.
no, no,
BCD
not
adder interface. See, I will
yes.
create an
One is
instance of the
object
BCD adder interface
instance.
called my
Yes.
bus or something like that.
And inside
So
bracket
my
you put the
bus.
object.
Here I'll you know uh, the first thing I have to give is the um, my bus dot bcd
Yes.
in a. How do I initialize it to some random value?
You random range
Yeah,
and we can give any value 0 to 9.
good. We have understood. Correct.
Yes.
Who else? Anybody else? Let me pick on somebody. Jayaprakash. Correct. So here the carry is 0 to between 0 and
Yes.
then we have to see these things have to be done inside the initial block. Okay, this has to be done inside the initial block. So first you put all the hardware, then you should do all this.
Now we can display the values.
No, now we have to wait for 1 minute. See, if you immediately display, then it will show X. Okay, you should wait Then you can display. So what are the things? I am trying to display my bus or BCD in A, my bus or BCD in B,
And
then my
carrying
bus dot BCD, no, just carry in. I think here I have called it BCD carry in, so maybe here also you can see. Okay.
yes.
Then
So in
outputs
line
are
15, line 15 should we not pass the interface?
what?
In line 15, should we not pass the interface in the instantiation?
Yeah, we'll we have to put that my bus. Yes. Then comes my bus dot BCD somehow.
Somehow, then carry out.
And what I'm going to do is I'm going to multiply the carry by 10 because that is the actual value, isn't it? See, if I get 1 as a carry, its weight will be 1, 10, isn't it?
Yes.
Suppose I add 6 plus 9, I get 15, but it will show 1 as a carry and 5 as the sum. So 1 times 10 plus 5 is the actual answer. Correct, no?
Yes.
So the reason it is saying that is hmm, let's make it clear also. Maybe ways and designs of software. This was working earlier, no? This was working earlier.
So should we not to use the same variable name inside the interface and inside the design, or is it flexible?
I don't understand why when it works here, why is it not working in the design that is there's some problem. See, I think
So maybe the data type is not recognized.
no, see if I put them in the same file it is working. But if I put them in design here and this one, I don't see it works here. I mean it works if I put everything in this file. So let me try moving. Such thing should not happen here. See, here it works. Suppose I move all of this to the right. See, there is some problem. So you have to be used to this, guys. See, this is something we can't entirely avoid. Okay, you will have some bugs in the tools also. So we have to live with them. Okay.
So some features may not be enabled because it's a free tool.
No, no, no. This is on. I think that may not be the reason. There is some problem in the tool. Yeah, I don't think that. See, this is not such a complex thing. Okay, it works. No problem.
When the type def is there in both in one place,
Hmm,
it works.
hmm.
When type def gets separated, design and test bench side, it gives error.
Hmm. I don't know. If you put everything in, see, this is bad, right? It should not be like this. Okay, I'll just leave a comment here. Any questions so far? So we have covered quite a few things. We have covered mostly all the data types, classes, interfaces. Any questions? Kandarpa Kumar, any questions from you? Kaustubh Sarkar, Hemadarshini, Harish Patil, okay, good. All right, let us try this exercise. Design a multiplier. So let us design a shift and add multiplier. So our interest is in multiplying, let us say 5 with maybe 3 or something. So the shift and add multiplier mimics the way we do the multiplication, right? When we see a 1, we sort of copy this down, and when we see a 0, we just have all zeros, right? So it is going to do exactly like that. So it will use a register called A, accumulator, and another called Q. This is where we load initially zeros, and initially one of these is called as a multiplier. Let us say this is a multiplier and this is a multiplicand. So we can load any one of them. Let us say this is a multiplier. The multiplicand is kept in a separate register. So there will be 4 steps. Step 1. 4 steps because there are 4 bits. So we look at this bit 1. We have to look at all the bits one by one. Just like when we multiply, we look at each bit, right? In the same way, we look at this bit. And if it is 1, we add this 0, 0, 1 to A. And we write shift. So add and shift. Step 2. Here it's just a 0. So simply shift. In step 3, add and shift. So add 0011 and shift. Last step 4. We see a 0, so simply shift. So this is the actual product. And this represents the value 15. So when we multiplied 5 and 3, the answer is 50. So if this is clear, let's otherwise we'll do one more exercise. So these are treated as unsigned numbers. This is unsigned. So suppose we take a larger number, maybe 15 times 50. So accumulator is initially 0, Q is 1, and the multiplicand is 1, 1. So we look at step 1. 1 means we add the multiplicand. And then shift. And 0 will come. This is not a signed number, it's an unsigned number. Step 2. So we have to add this and this. Okay. So what do you get? We have 1, 1, 1, 1. So that we are adding 0, 1, 1. So 1 plus 1 is 0, 1 plus 1 plus 1 is 1, 1 plus 1 plus 1 is 1, 1 plus 1 is 0. Then we will get 1 and 0, 1, 1. Then shift. Then step 3. Again there is a 1. Okay, so add and shift. So this time 1011 is being added to 111. 1 plus 1 0, 1 plus 1 plus 1 is 1, 1 plus 1 is 0, 1 plus 1 plus 1 is 1. I'll get 1, then 1 0 1 0. And I'll get 0 1 1. Then shift. And again 1. So we are going to add 1101 to 111. 1 plus 1 0, 1 plus 1 0, 1 plus 1 plus 1 is 1, 1 plus 1. I'll get 1 followed by 1100. We get 0, 0, 1. And shift. So 15 times 15 should be 225. This is what this is. This is 2 to the power 7, right? 128. This is 64. The next is 32. And the last one is 1. 8 plus 4, 12, 12 plus 2, 24, 24 plus 1 is 25. 4 plus 6, 10, 10 plus. That's correct. 8 plus 4, 12, 12 plus 2, 24, 14 plus 1, 15, 3, 9, 9 plus 3, 12. Okay. So this is 225. So the answer is correct. Is the idea clear to everybody how it is done? So the challenge is, oh, Dhruvang Patel is saying no. Okay, let me try again. See, I'm glad Dhruvang Patel you spoke up. You said I didn't understand. So we have 3 registers. A register, Q register, and M register. We load the multiplier here. So let us pretend that the multiplier is take any 4-bit number. Let us say we take 12, and then we take maybe 13 or something. So 12 is 1100, and A is initially 000, and the multiplicand is 13. Wrong, is that clear? How did we load? We just loaded the multiplicand in M, accumulator is 0, and multiplier is loaded. All right. Italy Das. Very good. Now we have to look at the bits of Q one by one. We always look at the last bit or the least significant bit. Okay. If it is a 0, we have to simply right shift A and Q. So you assume that there is a carry here. Initialize that to 0. So that 0 will come here. This last 0 will come here. 1, 1, 0. So this is a shift operation. If you see a 0, simply shift. This is step 1. In step 2, we again look at this bit and say, hey, this is just 0. So just shift. 0, 0, 0, 0, 0, 0, 1. Now we look at this 1. So when we see a 1, we have to add the multiplicand. So what do we get? 1, 0, 1, 1. No carry. And this retains its old value, 0, 0, 1. Right shift the whole thing. 0, 1, 1, 0, 1, 0, 0, 1. So add and shift. Again, we look at the last bit. it happens to be 1. So add the multiplicand. One one zero one. We get 1. 1 plus 0 is 1. 1 plus 1 is 0. 1 plus 1 is 0 and carry is 1. Then here we have 1 0 0. This is after add. Then shift. This 1 will come here. 0 0 1. This one will shift here. 1 0 0. When you multiply 12 by 13, 12 threes are 36. 3s are 12 ones are 12. 12 plus 3 is 156. Here we are seeing 1001. Its weight is 128. This guy is 16. This guy is 8. This guy is 4. So 8 plus 6, 14. 14 plus 8 is 22. 22 plus 4 is 26. 2 plus 2, 4. 4 plus 1 is 5. And this is. So they are the same. Okay, add and shift. Okay. Let us see this thing and we'll try to understand. Yeah, give me a minute. Oops. So we load accumulator with 0. We load Q with the multiplier. We load M with the multiplicand. There is a carry bit will initialize to 0. And count equal to, let us say in our example 4. Okay. It can be the actual size of the registers. So what is the first step? Q0. That is the least significant bit of Q0. We check if it is equal to 1. Maybe true, maybe false. If it is true, we will add accumulator to the multiplier and that will generate a 5-bit number. So we'll put it in C, comma A. So this is a 4-bit number, this is a 4-bit number. When I add, I'll get a 5-bit number that will sit in carry and A. And in both the cases, I will have to shift the accumulator and the Q together. Okay. So C, A and Q 3 to 1. So these are the 3 bits of Q. This is 4 bits of A, and this is a carry. These guys will go into A and C. Totally 8 bits. 4 plus 4 is 8 bits. This is 4, this is 3, and this is. After that, we will count equal to count minus 1. Check if count has become 0. If yes, we stop. Otherwise, we go back. When we stop, A and Q have the product. Okay. Is this clear now? Somebody asked a question now. Devang or somebody. Harish Patil. So please use system Verilog. Use any of the things that you have used. You can use a class. You can use um, use any of the data structures that we talked about. Okay? So now the options are open to you. Okay? The options are open to you. There will be several solutions. Okay, there is no one solution. The model, the shift and add multiplier. In system Verilog and test. Okay. Test it, and that will be the assignment. Okay. So think about it and tell me. I want all of you to think for a few minutes. I hope everybody is sitting with some paper and pencil. Or are you sitting with your mobile phone, with WhatsApp? So this is a sequential circuit or a combinational circuit? Lango. Yes. This is a sequential circuit. So when you build the model, see, you can do it very accurate to the hardware, or you can just model the algorithm, right? You can be like a software developer and just develop the model. Okay. Or you can do very close to hardware. So if you are a designer, you will use the Verilog and try to create something that can be synthesized. When synthesis tools were not there, they had to build this by hand, meaning, you see, this will require a adder subtractor. It will require an adder. It will require an adder. So it may require an n-bit adder. Then maybe some 3 registers are required. and there are possibly some comparators, etc., some control logic. All these things are required. Counter. So many years ago, students used to design this by hand and directly go to a layout tool and draw the transistors. Okay. The disadvantage of that is, see, if they make one mistake, changing it is so difficult. If you have already done the layout and you realize that there is small thing that is wrong and you have to read, it's very, very difficult. So therefore, today it's possible to model it at a very high level in languages like Verilog, and in fact, they can even synthesize the logic for you. You don't have to worry about, and they if you have the gate level logic, the tools can also place and route for you, isn't it? So try to model the sequential circuit. What do you need for a sequential circuit? What do you need for a? Can you try? So if you build a shift and add multiplier, what will be the inputs? What will be the outputs? Rajesh, Sevugan Rajesh. Hmm. Who else is there? Abhishek, what are the inputs and outputs, man? Akash, somebody is answering. Professor is answering. I'm so happy that the professor is answering. So absolutely right, professor. This is you need a sequence. You need a clock. You need a reset. You need the multiplier. You need the multiplicand. Anything else? And what will it produce as output? It will produce a product. And maybe it can also say that I am done, finished, I am ready with the product. Because it's a sequential logic, so it may need to say something like I am done. Okay. So the external test bench or some circuit that uses this module will the protocol is place multiplier and multiplicand. then apply a reset, then apply clocks. Then wait for finish. When finish is done, load the product. Otherwise, how will you know that it is done? So this is what you have to model. You can use any one of the things. You can do it the way we were doing it the early days. In the first few days, we did not use class and all those things. Okay. So that is fine too. Okay. Or use, build a class. Anybody wants to get started? What do you think is a good idea? See, if possible, try to build the interface also, right? That is where, after all, we have learned all these things so that we can apply them. Okay. So build the interface. Shift and add multiplier. So you may want to have an interface. You may have to have a class called shift and add multiplier. You may need a test module. You may need a way to generate random inputs or whatever to generate inputs. And you may need a way to test if the results are okay. So you need to think about all these things and then build a model. So will you give it a try? Oh, Ilango has answered. Very good, Ilango. You have given the answer. Multiplier, multiplier. Correct. It's correct answer. Harish also has given the answer. Multiplier, Q, yeah. And if possible, build it as a, and don't restrict it to 3 bits. Okay. N bit if possible. So that tomorrow, if you want to use it for 8 bit, you can do it. That clear? So will you give it a try? So today, sit down after the class and don't get up till you solve the problem. It doesn't matter if it doesn't work. Don't worry about it. Okay. It may not work because you are seeing syntax errors. It may not work because maybe the answers are incorrect. Doesn't matter. Then we can fix it. Once you have the first version, we can debug it. What Shanti? Will you try? Neha Kumari. Tejas Raichura. MP Singh. Ekagrasika. Will try? Oh, somebody already gave some answer. Very nice. Who is this? Module shift and add multiplier. Very good. Input logic start. They have also given a start button. Good. Then 8-bit inputs A and B. Product is 16-bit. Very good. Yes, this is a good starting point. Very good. Very good. So maybe we'll meet tomorrow and continue and develop the complete model for shift and add multiplier. The same shift and add multiplier can be extended to become a signed multiplier. See, this one is meant for unsigned numbers. Okay? You can extend it to work for signed numbers also. And there are also some variations like Booth's algorithm and so on. Okay? So once you learn this, many other related circuits can be done. Okay? All right, I'll see you tomorrow then. Vinith, shall we close? Administrators, can we close? Itli Das. Itli Das is saying something.
Sir, tomorrow should we meet at same time, 12 o'clock or 10 o'clock?
I'm open to whatever suggestion you have.
Sir,
Tomorrow
we
I
have
don't.
announced
See,
10
today I
a.m.
had a
10 a.m.
conflict, so I requested you to do it at 12.
Sir.
Today, was it supposed to go on till 7 o'clock by chance?
Sir,
Oh, we were supposed to go till 12 today, at 7 o'clock today?
today, sir?
Ah,
No, 5 hours was there, sir.
okay. We finished 5 hours,
Yes.
didn't we? Yeah.
Sir,
So tomorrow, I think people are preferring 12 o'clock. Okay. So
fine,
we'll
sir.
meet at 12. Okay.
Sir,
All right. I'll send you the
thank you,
files
sir.
and okay. Tomorrow, 12 o'clock. Bye bye.
Sure, sir. Sir, thank you, sir.
Okay. Bye.